I have started the recording. Good morning, everybody. For today, we are focusing on a review of the where clause, material we covered for assignment 2. I will also answer any questions you all may have regarding assignment 2. And then we'll get into the third segment in the course, which is going through working with more than one table. When we end up working with one table, there is a technical concept called joins that we end up using, which is what I will introduce today. I expect to kindly expect that we will go through different types of joins today and possibly next Tuesday. And you will be able to start working on assignment 3, but we may not have covered everything there is to know for completing assignment 3, although a large chunk of it will be covered today. To put things in motion, I want to talk about data restrictions as described in this PowerPoint that you all have access to. We talked last time about the where clause, and you can clearly see the where clause is used with select statement. It's also used with update statements. But right now we are focused generally on the select statement. Where clause can have different types of operators, as you will see in this PowerPoint deck. So where clause is used to filter out unwanted rows from a data set. And the way things work in SQL is that when you have a select statement like this, it's going to bring out all the rows, and then when the where clause is added, it might filter out the rows we don't want and give us the rest. So we are sort of working with sets here, if you will. Set being rows and columns of data that we get, and we control the columns we want to select by providing the names of the columns in a given data set, and the where clause controls the rows that we will end up seeing and the rows that will end up getting eliminated. So a condition is written like this, where sal greater than 3000. So you can use a bunch of relational and logical operators that you will see play through. We're going to spend a lot of time on Cartesian product today, so I'm going to skip right through it. We can write a where clause with one or more condition using and, or operators. Several different types of operators. So, several facts about the where clause. Expressions and the different types of operators we talked about. So, in a nutshell, we're going to use where clause in an update statement as well. And this helps us limit the number of rows we end up updating. To the contrary, if the update statement is not, if the update statement does not have a where clause, then we end up updating everything. Update with select. Very, very powerful. Arithmetic operators in expressions, like in the where condition. Notion of operator precedence, evaluation, the priority in which the different operators are evaluated. And you can use parentheses to enforce your own priority. We've got several different kinds of operators: comparison, concatenation, character, logical, and in and between. Depending on the data type, these operators behave differently. Relational, single and multiple row. And then, of course, you have your is null operator that works with the null value. We have in any and all, which is working with a set of values, not applicable in assignment 2, but will be talked about in detail in the future. When you work with multiple strings, you end up using a concatenate operator, like so. The result is that strings get concatenated. Pattern matching, extremely useful in assignment 2, where you provide a % clause, and by using the % clause, we are in a position to do wildcard searches. Like using an underscore with comparing one character at a time. Defining your own escape character. So if you're trying to search for a backslash or an underscore, you would use the keyword escape and then provide your own escape character. And then we have the logical operators. And my favorite slide for the different logical operators is this one, that quickly highlights the outcomes of when two conditions are applied together. Very handy. And who's to stop you from using more than one condition with different logical operators? We also have in operator, where we have more than one value, but we also use the between operator, where, so just to talk briefly about the between operator, we have this. Keep in mind the values are inclusive, right? And then, of course, there's a lot of information on null values and how to treat those. In a nutshell, null values are there to save a space. It's declared once in the database engine itself, but later the null value is used so it can basically represent basically an inapplicable or unassigned value for any data type. The reason it was created is so it saves us a ton of space in the database. So, having looked at this content and your work on the second assignment, I just wanted to open it up for any specific questions you may have as you are working on assignment number 2. You all know that there is a discussion group created on piazza.com where questions can be posted. If this is by invitation only, so people that are registered in the class will continue to have access to it. If you have dropped the class, then that access will be removed. The list is going to be reconciled after the drop period is over with later this week. So you can post questions there and get those answered. You can also email me or set up a time. When you look at this assignment, it's asking you to use different parts of the where clause, essentially. I want to leave, I'm going to go be quiet for about 30 seconds. Does anybody have any questions that they would like to ask on assignment 2? To work on 3, do we need to work on modified tables of 2? No, you'll just continue working on the database that you already have. So no, nothing needs to change. And we are only doing select statements in number 2. So once you have ran the script that I'm pointing to on the top of the screen, when you have ran the script, your database is pretty much set for the entire quarter. Any other questions? Okay. Let's move on to the next topic, which is working with more than one table. So working with data using multiple tables, this concept is called a join. So join is working with more than one table to extract data in a select statement. So how does this actually work? So let me bring in Excel so I can just, show some data set and try to provide an idea for what a join looks like. So I'm sure you can all see this. We'll have the employee table and the department table. Employee table will pick a few columns: employee number, name, salary, and department ID. Here we will have department number, department name, and location. And let's go ahead and add a few employees and a couple of departments. So these are columns, and it just so happens that each table has a primary key and a foreign key as represented here. And now we want to create a query so we can print department numbers for all, department name and location for all employees. If that makes sense. So essentially what we're trying to do is create a query where we'll have employee number, name, salary, department name, and location. That's the output we are looking for. You can zoom in locally as well, Gianni. I'm happy to do that, but you can also do that locally in your screen and magnify to a specific part of the screen if as you see fit. Okay, but I did what I could. Is that hopefully that is better. So what this means is that for employee number 1, I want to print out all this information. Something like that. So to create this query, the way database will work is we will need to first select all columns from, I'll need to select not all, but select columns from each table. So we will say select emp number, comma, name, salary, department name, and location. And we will end, because we are now providing columns from department table, we will need to specify both of those table names. So we'll say from EMP, comma, department, semicolon. So what that is going to do inside this, what this little query or part of the query is going to do in the database is, it's going to say, all right, you want all that info. Let me show you what is called a Cartesian product. So I'll say 1, Bob, 50,000, engineering, SV, and then I'll say sales, SV. And then you can expect the same for the other 2 employees. So Cartesian product is a concept where we multiply the 2 sets. So Cartesian product is multiplying 2 sets. Can you all see that clearly, everybody? And everyone can hear me okay? So when we get the Cartesian product like this, we basically get values from each row. We get values from each row from one table represented with values from the other table. So in my department table, for example, I have 2 rows. So if I had 5, then my Cartesian product would have had 3 times 5, 15 rows. because I only have 2, I take each employee represented in each department. So this is what we mean by joining 2 tables. When we start working with more than 1 table, we actually first of all multiply the set in memory, and the results look like this. And to this statement, then we add a where clause. So we don't have semicolon here. What we do is we have in the where clause, we end up specifying a join condition. So we'll say where emp dot department number is equal to department dot department number. So I'm relying on the foreign key in the employee table and the primary key in the department table. I already have a primary key with values 1 and 2. These are unique values, definition of the primary key if you may recall. And I go in the department table and reference the primary key. So it in a way is form of a link to it's a form of a link from the employee table into the department table, because when I say department ID 1, I mean all of this. When I say 2, I mean all of this. So now when I say where employee.department number equals department.department number, even though I'm not selecting these values, in the where clause I can use these. So allow me to do the following. I will look at the department number in employee table and department number in the department table. And this is literally to show you how these two will work. So when I look at employee.department number, when I'm referring to the data from the employee table, this is going to be what? 1 and 1. Because I'm getting the value from the, I'm getting the department ID from the department table. In fact, I should call this department number, not department ID, for absolute reference. And then when I look at the department table, I'm going to bring in these 2 values, 1 and 2. Similarly for Harry, it will be number 2, and it will be 1 and 2 respectively here. And for Sally, it's going to be 1, and it's going to be 1 and 2 here. So this is, whether we select this or not, as part of the Cartesian product, when we start using this kind of a condition, when we start using it, this part is formulated. And so what we're going to do is we're going to execute this condition and only select the rows where the values in fact match. So values match here, here, and here. So these 3 rows that I just colored are the ones that will be selected, and these will be eliminated. The ones with the white background will be eliminated because the values don't match. So as a result, I'll end up with my final result that will show for the query is going to show like that. It's going to remove these two rows, and it's also going to remove this row. And so I end up with, the right department information for each employee. Why department number in department is different from department number in employee? Well, in department, it's a primary key and we are trying to describe all the departments. When we use department number as a foreign key, we are trying to say which department a specific employee is in. So Bob is in engineering, Harry is in sales, Sally is in engineering. Does that make sense? Does that answer your question? Please let me know if it does not. Okay. So what we just talked about was how a Cartesian product is created and processed with a join condition. This being the join condition in the where clause. How's everyone in the room doing? Is this concept pretty clear for everybody? Can I please get a quick response from all of you? And we'll move on if things look good. And if not, I'm happy to address any questions you all may have. Once the concept is clear, I think it becomes pretty easy to work with joins. This is the foundation. That's why the importance of the topic. Okay, so now we move on to how joins work syntactically. There are different types of joins. So what I just described is repeated in the slides in words and also perhaps another example. So joins are used to query data from multiple tables or a view. We haven't talked about views yet. Views are virtual tables. Views are like you create a select statement and you make a table out of the select statement so you don't have to keep retyping the query. It's simplifying the query essentially. So it's views created from a select statement. In a join, rows in one table can be joined to rows in another table using primary and foreign key, as I showed. And it requires usage of the where clause. If a where clause is not used, you have a Cartesian product where in the example I was trying to show earlier, you might see employees in the wrong departments without the join condition. So in a join, when you want to create a join in a from clause, you end up putting two or more tables separated by commas in the from clause. And select can have columns from multiple tables. And then where clause has the join condition which will end up limiting the number of rows that would be selected for a given query. The syntax usually looks like this. One thing I did not mention was the creation of an alias, so you don't have to type the entire table name either when you're specifying columns in the join condition or in the select list. So it's possible for more than one column to have the same name across tables. And so using the alias or table name to qualify the column names is a pretty solid way to represent a column name to simply avoid ambiguity around column names that may be duplicate in one query. The concept of a Cartesian product is implemented for processing joins in a database. So a Cartesian product is nothing but a number of rows from one table multiplied with the number of rows in another table. So for example, if I have two tables, one with 5 rows, another with 10, the Cartesian product will end up having 50 rows. If I have 3 tables, one with 5, one with 10, another with 2, then I'll end up with a total of 100 rows. 5 times 10 times 2. That's going to be the total mass of rows that I would be selecting from, and then the where clause will help eliminate. The purpose of joins is so we can put information about different entities in different tables without and not have to waste space. For example, if I go into the employee table, and for a moment if I assume that I'm not going to have this table at all and I need to save department name and location for each department, I can put that as part of the employee table. So if I was General Electric and I had like 500,000 employees and I had let's say I have 20 departments, I'll be duplicating the information about engineering or sales. I'll be repeating that information multiple times. And so what we are trying to do by creating a separate table is avoid repeatability and improve query performance by reducing the size of the database. This is the intention when working with relational databases. Is everyone able to hear me okay? Just want to double check. Okay. So Cartesian product is created like this. And then the where clause is specified, which will provide the relationship between two tables. And for the most part, join condition is specified by using the primary key and foreign key. So and that's what helps in limiting the rows. These are some of the rules we end up using for the join condition. So total number of conditions is usually number of tables minus 1. If I have 5 tables, 4 join conditions, and so on. It will involve compatible column types, meaning you cannot take a number type and say number is equal to string, because then the equality operator that is being used for the join condition is going to fail. Column in the join condition do not have to be put in the select list. like I did in my example. I did not include department number from department or employee table in my select list, but yet I showed that as part of the join that I was pursuing. It generally involves the equality operator, but it can use other operators. And this is not to say that you can't have additional search conditions, but the way the where clause is written, when you have more than one table in the join, you write the join condition first and then any other conditions that you want to use for eliminating rows from that query. Join condition is always first. So we're going to get categorical on the joins and go through what the different types are. So if you are using an equality operator, it's called an equijoin. If you are using another if you are using any other operator, then we will call that a non-equijoin. Non-equijoin is, this is what a non-equi would look like. This is what a non-equi join would look like. Like we are using the between operator. We can also use greater than and less than and so on. So this is just a light introduction to non-equi and equi joins. See, non-equi and equi can apply to any one of these joins. So technically there are three types of joins that we need to get to know: inner, outer, and self. I'm going to go through each one separately, providing examples and not rushing through this topic. Technical competence on joins is crucial for a database analyst working with relational databases. Very important. So please take the time to thoroughly understand how these joins work, first of all, from a technical perspective. And then the next thing would be to be able to explain in words what each join condition means. Lack of that usually is not good in interviews, as you might understand. So we'll work with these two tables for the rest of the examples. We actually started working with that. So inner join is a regular join. So what happens in an inner join is something like this. When the condition satisfies and selects data from both tables where the condition works, like we did in this case. Lexicon used to describe this is in the slide. So inner join is like a regular join which satisfies the join condition. Each row returned by an inner join contains data from tables involved in that join. So then the next question is, well, what else is possible, right? And that's why we have outer joins and self-equi joins. This is how an inner join is written with another condition. So we've already talked about this top part with the select from and where. But we also said let's add this guy where we say ename equals Ford. So by adding ename equals Ford, we take the result from the intersection and eliminate rows further because we are using an AND operator. So like in my picture, if I'm getting 3 rows and I said ename is equal to Bob or name is equal to Bob, then I would select just that row. And if I'm selecting the first 5 columns, I'll just select those 5. I think visuals are helpful when processing data. So in a matter of speaking, when we did an inner join, we looked at all possibilities and then did an intersection between the two sets. That's an inner join when we use an intersection. When we have an outer join, it's an extension of the inner join. Here the rows that are returned satisfy the join condition and also bring out rows from one table for which there may not be corresponding rows in another table. Usually I look at the second bullet point and raise a question as to what it really means. So I think it's best seen when we actually see it in action. So we actually use a join, an outer join operator with a plus sign, whether it's right or left, depending on where we put the plus operator. So what we are trying to say is, to work with a outer join, we would have something like this. We would put a plus sign on the left side or the right side. Let's have a look at some real data instead of playing in Excel. Let's look at some real data. So I will go ahead and write some queries on the fly and run those. I'm using a text file as a placeholder for the queries that I'm going to be writing. So we'll say select star. Actually, let's bring in specific columns. So we'll say employee number, employee name, E dot department number, D dot department number, and D dot, I'm not sure if it's called E name or D name. So we'll describe the department table. So we'll say department dot D name from employee E, department D. where E dot department number is equal to D dot department number. That's a regular join. So as you see this value, you should see a total of 14 rows, where both of these conditions, you can see that the join condition is satisfied, so we are selecting those rows, right? So now if I put a plus sign on the left side, let's see what happens. It brings in 15 rows. So it brings out an extra row in the department table that does not have any employees. Just kind of like the way you see in the slide 2, right? Right here. So same story. So when I run this query and I say, I put the plus sign on the left side, it's bringing in departments that do not have any employees. That's like the best way to explain it. So I can do the same thing, and so writing a query like this basically means show departments with no employees. Well, in addition to all departments with employees, right? Show department with no employee. Does that make sense? So that's beginning to give you an idea of how outer joins actually work. So if I take this plus sign and put it on the right side, right? So let's remove this and put it on the right side. So now I'll get, in addition to all departments with employees, show employees or show employee info with no department, because we can have certain employees that that haven't been assigned a department yet. So the thing though, what we can't do is put the plus sign on both sides all together at the same time. This is not allowed. This will throw an error, because the way this join syntax is set up, it does not allow usage of the plus operator twice in the same select statement. So when we are looking at outer joins and just trying to describe the outer joins, we can use the second bullet point or the fourth bullet point to try and provide some insight into how an outer join should be defined. But let's not do this. Let's, when you are confronted with a question in an interview on, hey, how does an outer join work? Then my suggestion is, well, just throw the data in front of your interviewee, throw some data in front of them, right, in two tables, and then show how it actually works. And the words that the second and fourth bullet point provide an insight to me, but what makes it abundantly clear is this kind of a statement with an example that, hey, I'm trying to get all the information that I can with an inner join plus an entity that doesn't have corresponding rows in another table. So, if I say employees and department, it then becomes very clear, like, okay, all the employees that don't have departments or all the departments that don't have employees. You see, trying to put that in abstract terms causes confusion and therefore shows, even though you know the concept, it shows lack of your understanding. So expressing it in an example and showing what it is will provide your interviewer clarity on what you know. So, and that's important. Knowing the concept is one thing, but being able to communicate is another. And that's what I'm trying to impress upon you in this conversation. Okay? So there are several restrictions on outer joins as I described. This is one of many. Before I continue, I want to make sure that the concept of outer join is clear to you guys. Any questions that I can potentially help address at this time? I'll wait here for a few seconds in case you guys are typing a question. So can I assume all is good then? And just keep going? Okay. All right. So if a join involves more than two tables, then one table cannot be joined with more than once. It cannot be joined with more than one table in a query. So what we are trying to say is that here we are trying to take the employee table twice in a join condition. And that is disallowed. So here we are saying let's take department number and grade and try to do a two-way join between using the employee table. And that will not work. Workaround, create a view. So we'll learn how to create a view and then join the table with a view. So another restriction, cannot use in operator in a join condition. Can only use equality. Well, I can't say only equality. We can use relational operators in a join condition. But any of these multi-row operators where you have the like in, any, and all are not allowed. This will simply throw a syntax error. Here's another restriction. Outer join condition may not be combined with any other condition using an OR operator. So when you use a outer join, you always have to use an AND operator. Otherwise, if you try and do an OR, it's going to produce an invalid query. Other thing is that just like we can't use an in operator, we cannot also use a subquery with a outer join. Won't work. will return will return an error. So, okay. So the workaround that we had talked about earlier, like creating a subquery or creating a query in a clause like this. So we have a select statement in a from clause, and we are taking that and creating referring an alias. So this in effect becomes a table to select from. And so you can see that I can refer to the department number with that is selected from that subquery. So this is a really good workaround. So like we cannot put a subquery like that, but we can put it in the from clause and then do a join, which works effectively. Then we have a concept of a full outer join, where we take the results from left and right combined. So in other words, if I wanted to say that I want all the employees that are assigned to a department, all the departments that do not have an employee, and all the employees that do not have a department. We're going to take we're going to take all of those three things combined as an output of our query, and that refers to a full outer join. And another way to express that is in these three bullet slides. Results from the inner join, from A where there is no corresponding rows in B, from B where there are no corresponding rows in A. That's basically saying departments that have no employees and employees that are not assigned to a department. So assuming full outer join for location and department, right? So you can see that there are 3 locations and we have 4 departments. One of them doesn't have a location ID, right? So these are some assumptions we are making, assuming that there are locations in location table that do not have corresponding department. At the same time, there are departments that don't have a corresponding location ID. When we do a full outer join, we're going to first do an inner join, which will bring us data, which will bring us the intersection, meaning all locations, all departments that have assigned location. So all departments that have an assigned location. Here we get a location that doesn't have any departments. And here we have a department that doesn't have a location. So it doesn't know like operation belongs to which regional group. And here Chicago, we don't know what departments there are. So if we wanted to do a full outer join, we would use the keyword union. So which is done like this. We basically have the exactly same query, but in one case we have the plus sign on left side and right side. That's a union, which is similar to a full outer join. So what that brings is the following result. Operations that, or Department 40 doesn't have a regional group or doesn't have a location, and location Chicago doesn't have any departments assigned yet. So that's the concept of that's a concept of a full outer join. So, okay. So this should give you a pretty good start to assignment 3, excuse me. So there's a lot more to cover. So one more thing I'm going to look at for today, so you can in fact get to your assignment, is the concept of a self-equi join. This guy right here, self-joins. A very impressive concept. And what I'll do is in fact take some time and we'll review this again in our next lecture. So, is everyone doing okay, guys? Any questions from anyone? Everyone still awake and with me? Sorry, we're online, so I end up asking such questions. So, all right, guys. So we're going to continue working with joins, and we're going to talk about self-equi joins. One recommendation I have for the lab assignment is to use, we're going to talk about a new syntax as well, but I would recommend using the old syntax, like usage of this plus operator and union. And we're going to talk about the new join syntax down the road, maybe in a few, like next time. So I'd like to get through so let's look at self-equi joins. And we're not going to talk about the new syntax today. So self-equi join is when you make a copy of the same table, and so treat one table as 2 and do a join using an equality operator. Now the question that comes up is, well, why would we want to do something like that? So the proof is in front of you. We have manager that's also an employee. So 7566 is actually Ford, and Ford's manager is 7567. That is Smith. Smith is also the manager for Martin, because we can see that in the MGR ID, right? So what we are trying to do is join this table so we can bring out manager's information. So if we wanted to, for example, print a list like who reports to who, then we can do that with a self-equi join. So later on when we work with creating tables, we're going to learn how we can create such relationships where one column is linked to another column in the same table. I repeat, we will learn in the future how we can take one column and link it to another column in the same table. So it's still that primary key, foreign key concept, but it's all in one table. So here what we do is we use the employee table and select from it twice. And we end up saying, let's use the MGR column with the employee number column in the same table. So it's used when one row of a table is used when a row of a table is linked to another table using equality. So this is a self-equi join. You're going to end up using this also in your third assignment. So we also have self-outer equi join, where we can bring out a manager that doesn't have any employees. Like if a person doesn't have a manager assigned, or a manager does not have employees assigned, we can, I'm sure you can quickly see the notion of outer joins applied to the self-equi join, right? So in this example, we are saying that we are going to select employee table data from employee table twice. In one case, we're going to reflect on one table as a worker table, table that has data for workers, and another where this alias is indicating that data is being treated as data from, manager. And then we say worker.mgr. So when we say worker.mgr, we are referring to the mgr column in the database. So if I was to describe the employee table for a moment, you can see there is an mgr column in the database, in that table. So when we say worker.mgr, we are using that column. And we happen to use mgr as an alias for a table, which is the same as the column name, and that is a little bit confusing. But it's really, when we say mgr now here and we say mgr.employee number, we are referring to the employee number for the manager. And then we take the, intersection plus the one or two rows where there aren't any corresponding rows in the MGR representation, and we bring that data out. Okay. We also have non-equi joins where we can use an inequality or a we don't use the equality operator, we use any other operator other than the equality operator. Okay. We can go ahead and join more than two tables. And if we do so, like in this case, we are joining employee department and salary, and so you end up with two conditions. So this is one join condition, this is another join condition, and this one is just a third we just have a third condition. So I think I'm going to leave the new syntax for next time. But what I would like to do is look at assignment 3 briefly. So I can give you some hints on each of these questions. So in the first question, it says write a query to display employee number, name, hire date, and manager's name. So this question is going to require using use a self-equi join. You'll have to use a self-equi join here. So when we do that, we might have to somehow account for bringing in manager names that starts with KMNF, and you can only do that once you know the manager's name for a given employee. The next query says create a query that will display employee name, department number, name, and all the employees that work in the same department as a given employee. So this is a given employee means any employee you choose in the where clause. So you can say where ename equals king, and that becomes the given employee. So this should use an inner join to join employee and department table. This should use a self-equi join to join employee and employee table. This is a inner join between department and employees. So the join between department and employees table. The next one is an outer join. So I'm asking you to insert a new row, like a new department, and we'll create a query to make sure that you can display all the employees in 20 and 50. So, if you look at the data set, there are a few people in department 20, right? So we'll show those. And we're also going to show any employees in department 50. Of course, you'll not have any because you just inserted a new column. You just inserted a new row for department 50. So then we're doing the same thing for, so we'll end up using outer join here. And we'll also end up using an outer join here. So for doing this one, I am actually giving you a script to run. Otherwise, it'll become a little tricky. So what I'm asking is, well, you want to insert, here, let's look at the description first before I show you the script. You want to insert a new row in the employee table, so you can choose any values, but make sure the department number that is entered is null. So now we'll use a query to display all employees in all departments, which basically means a full outer join. all employees in all departments. So there may be departments that don't have employees. There will be employees that don't have a department, right? So we can use a full outer join to do this. And so the query I'm providing this help script, and if you take a look at it, it creates a table called employee2 for this question only. We're not going to use this for anything else. So you just run this, create employee2, and you're going to see that department number is the last column, right? And I'm entering a bunch of rows with null values for the department. Like here I have 20, 20, 30, and so on. But in this table I have last three rows. Scott, Adam, and Miller don't have any department number. And that's really for the outer join that I'm having you guys try out. Okay? This is to make your life a little easy so you're not stuck on creating data, creating tables and inserting data. You can focus on the query, and we can talk about creating tables down the road after the midterm, which is when we're going to do that. Okay? So that's assignment 3. So this is all I have for today. I'm going to go ahead and stop here and be around for any questions you all may have. So please go ahead and ask when you're ready. I want to go ahead and stop the recording now. So the syntax for using 2Ls can be, we are assuming 2Ls are next to each other. So I can say where ename like percent %LL%, right? But what I might say also is that I might want to trim the ename with any of the leading and trailing spaces there may be. So I'll say where trim ename. The function trim is going to get rid of leading and trailing spaces. So something like that, %LL%. And if I'm looking for a space like other characters between 2Ls, then I can consider adding a % here. But if I'm looking for 2Ls next to each other, then I can use this. Okay? So for assignment 3, question 5, I showed the script. So yeah, you can use this, and you can use this particular script for question 5 only. Questions 1 through 4 will use the existing script. Okay? I hope that answers your question. Any other questions people have? Hi guys, have a fun Tuesday. I'll see you same time, same place next week. Take care.